Yes, welcome students. In this class we are going to discuss about proving of these particular logical statements by two methods. Okay, so this is what we are going to do by two methods. We are going to prove this. The first method by truth table, and then by equivalence formula. We know that equivalence formula, that is, we are using so many equivalence formulas like De Morgan's law, associative law, idempotent law, commutative law, distributive law, like that. By using that also it is possible to prove the equivalence of one statement to the other statement. And here first we are going to prove by truth table method. Already I discussed this by taking so many problems. Here I am taking one more problem, and we have to find the truth table. Then we have to show that both sides are equal. That's why we have to. So here two statements are there. P is one statement, Q is another statement. So we have to prove that right hand side equals left hand side. Now look at that. This is what P implies Q. This is left hand side, and this is right hand side. We have to prove that both the truth value combinations are equal, and that's what our aim here. Now let us take the truth combination first. True, false, false. Now the truth values of Q we have to find out, and that is true, false, true, false. Now by using the formula implies we have to find out the truth values for the appropriate combinations. Here implies comes, therefore true implies true, you will have true. True implies false, you will have false. False implies true, you will have true. False implies false, you will have true. So P implies Q, we have found out. The left hand side we have found out. Now what is a negation of Q? We know already. This is a negative of Q, is a negation of Q. Therefore what we will have? We have here true, here we have false, here true, false. So we will have true, you have to get here false. Here false comes, so true has to come over here. Here true comes, false, and here false comes, here you have to get true. Now negation of P, the similar way we have to find out there. So negation of P are false, false, true, true. The negative of this we have to write here. So we have false, false, true, true. Now take these two compound statements. This is a one compound statement, this is another compound statement, and apply implies idea or implies connectives between these two. What you are getting is false implies false, you have to get true. True implies false, you have to get false. False implies true, you have to get true. And true implies true, you have to get true. And this is what the final formula. So what we are seeing here is that look at that, this column and this column are equal. Am I correct? In the sense that for appropriate combinations, the truth values are equal. Here also true for this combination. Here also true. For this combination, this and this are true. For this combination, this and this are true. For this combination, this and this are true. So that way at this column, I mean P implies Q is exactly equivalent to negation Q implies negation P. Okay, so look at that. At this column, P implies Q column, true, false, true, true is exactly equal to this column, true, false, true, true. Therefore, both the statements are equal, right? Okay. So thus we can prove the equivalency of the two formulas. P implies Q is exactly equal to negation Q and P. Okay. Now let us prove this by equivalence formula. By equivalence formula, it is possible to prove this. Now look at this. Now we have to prove that. So let me prove by let us have that. Now we will prove this by equivalence formula. Okay, for equivalence formula we are going to prove that by formula methods. We are proving the same, that is what we have here. Now look at that. P implies Q is exactly equivalent to negation Q implies negation P. That's what we are going to prove now by formula method. By formula method, it is possible to prove the same idea, that is P implies Q is exactly equal to negation Q implies negation P. Now let us prove that. P implies Q I have taken, that is left hand side I have taken, and this is exactly equal to negation P or Q, because from our truth table we know that A implies Q is exactly equivalent to negation A or Q. Sorry, your negation A should come there or Q should come here. Okay, so A implies Q is exactly equivalent to negation A here, not P, negation A or Q. So that formula is used here. Okay, now wait, we'll maximize this so that you can understand that very well. Okay, so that's what we have here. Now little okay, so P implies Q is exactly equivalent to negation P or Q by this particular rule, but actually here negation A or Q should come here. Now this is exactly equivalent to Q or negation P. How? By commutative rule. By commutative rule it is possible to make that. That is what is commutative rule says, A or B is equivalent to B or A. This is called commutative law. This is true for AND also, but here OR we are using. So negation P or Q would be exactly equal to Q or negation P. Okay, right. So this is exactly equivalent to the negation of negation Q or negation P. How? By double negation rule. What the double negation rule says that negation of negation A is equivalent to A. Negation of negation A is exactly equal to negation A. Sorry, A, not negation A. Negation of negation A. That is, for A you are taking negation, then again you are taking negation, this and this will cancel, you will get A. So that rule is applied here. Look at that here. So this Q can be written as negation of negation Q. A can be written as negation of negation A. So P can be written as negation of negation Q, or negation P. All others are same as it is. Now what rules I am using now is this rule. From here to here I am using now. Now look at that. This we can write it as negation Q implies negation P. Now from this step we can get this step. How? Again, one rule says that a negation U or C would be equal to U implies C. U implies C. Okay, that rule is applied from here to here. Negation U or C can be written as U implies C. So negation of negation Q or negation P can be written as negation of Q, that is negation of Q this, negation of Q this, that is U coming here, implies C. This negation Q comes here, this R can be replaced by implies negation P. Okay, so what we understand is that P implies Q is exactly equivalent to negation P or Q. Therefore what we understand is that P implies Q is exactly equivalent to negation Q implies negation P. So this is by equivalence formula method it is possible to prove this particular result, that is P implies Q is exactly equivalent to negation Q implies negation P. Okay, so in this particular class we have proved the same result by two methods. Okay, the same result by two methods we have proved, that is P implies Q implies and implied by negation Q minus negation P. That is, we have proved by two methods. First method by using truth table method, and we proved that the truth value of P implies Q and truth value of negation Q implies negation P or both are equal. The other method is formula method, where we have proved that P implies Q. At last we have negation Q implies negation P. So what we do there, we are using all equivalence rule, and at last we are proving this. Okay, so this is the way in the examination they may ask by truth table method or by equivalence method. So we must be knowing both the methods. Okay, so that's the way we have to prove. If they ask by truth table method, you have to follow this method. Suppose they are asking by formula method you prove, then we have to prove by this method. Okay, so with that I have to come to the end of this class. Thank you.